MS Ramaya University of Applied Sciences.
Hi students, let us discuss pulse width modulation and demodulation. The aim of the experiment is study of PWM using different sampling frequency. Pulse width modulation PWM is a powerful technique for controlling analog circuits with a microprocessor's digital outputs. PWM is employed in a wide variety of applications ranging from measurement and communications to power control and conversion. Definition: pulse width modulation is a technique that conforms a signal width, generally pulses, based on modulator signal information. The on-off behavior changes the average power of signal. A secondary use of PWM is to encode information for transmission. The apparatus required are Syntec 2110 kit with power cords, digital oscilloscope, probes and connecting cords. The connection diagram is as shown. Procedure is: connect the circuit as shown in figure 3.1 and also described below for clarity. 1 kHz sine wave output of function generator block to modulation input of PWM block. 8 kHz square wave output to pulse input of PWM block. Switch on the power supply and oscilloscope. Observe the PWM outputs at TP10 together with modulation signal input TP9. Vary the amplitude of sine wave and see its effect on width of pulse output. Also, change the frequency of the pulse by connecting the pulse input to different pulse frequencies 8 kHz, 16 kHz, 32 kHz and see the variations in the PWM output. Switch on fault number 1, 2 and 5 one by one and observe their effects on PWM output and tries to locate them. Switch off the power supply. The connection diagram is as shown. Connect the circuit as shown in figure 3.4 and also described below for clarity. 1 kHz sine wave output of function generator block to modulation input of PWM block. 8 kHz square wave output to pulse input. Output of PWM to input of low pass filter. Output of low pass filter to input of AC amplifier. Switch on the power supply and oscilloscope. Observe the waveform at the output of low pass filter TP12 together with modulation signal input 9. Then observe the demodulated output at the output of AC amplifier TP14 together with modulation signal input TP9. Vary the gain of AC amplifier to get the unclipped output. Vary the amplitude of input. The amplitude of output will vary. Now, connect the pulse input in the pulse width modulation block to the different frequencies available on board 8, 16, 32 kHz and observe their demodulated waveforms. Try varying the amplitude of sine wave signal. You will observe that the output signal varies similarly. Switch on the fault number 1, 2, 5 and 8 one by one at a time. Observe their effects on final output and try to locate them. Switch off the power supply.
Hi students, current experiment is pulse width modulation. Operators required for the pulse width modulation are Syntec board 2110 digital oscilloscope. Here we are going to conduct the pulse width modulation experiment. For the pulse width modulation experiment, we need a message signal of sine wave 1 kHz and the pulses of different frequency 8 kHz, 16 kHz, 32 kHz and the 64 kHz. We are going to feed the message modulation signal input, sine wave as the modulation signal input and the pulses of different frequency to the pulses input. Then we are going to get the pulse width modulated signal as the output from this block. Digital oscilloscope. This is digital oscilloscope. Main power switch of this digital oscilloscope is this one, and we have two channel this is a two channel oscilloscope, channel 1 and the channel 2. These are the magnitude adjusting knobs and these are the horizontal position adjusting knobs and this is the time scale adjusting knob. Probes for the oscilloscope and the connecting wires. Let us start the connections. for the Cytec 2110 board for the pulse width modulation experiment. Let us start the connection. Sine wave, which is modulating message signal also, that is connected to the modulation signal input. Pulse output of 32 kilohertz is connected to the pulse input of pulse width modulation block. Connect the probes for the channel 1 and the channel 2 of the digital oscilloscope. Channel 1 is connected to the message signal. Positive terminal is connected to the pin number 15, which gives the sinusoidal waveform, and the negative is connected to the ground. And channel 2 is connected to the output of the pulse width modulation, and negative is connected to the ground. Now connections are over. Let us switch on the oscilloscope and the Cytec board. In this yellow waveform, that is the input sine waveform, and these are the pulses with different amplitude, different width. So it can be seen, you can observe here, when amplitude increases, the pulse width is also increasing. When amplitude is decreasing, pulse width is also decreasing. Pulse width modulation block is explained. Now the next part of the experiment is going to be the pulse width demodulation. That I am going to explain now. As the pulse width modulation, the setup is the same as the previously shown. Now I am going to add the demodulation blocks which is required. Take the connecting wire. Output of the pulse width modulation is connected to the input of the low pass filter, and then the output of the low pass filter is connected to the input of the AC amplifier. Now there is a small change in the probe connection. Channel 2 probe is connected to the output of the AC amplifier instead of the pulse width modulation block. So I am connecting the channel 2 probe to the output of the AC amplifier. Now auto set the digital oscilloscope. Now see the output of the digital oscilloscope. Here this is the input sine wave, and after pulse width modulation and the demodulation, we are going to get the sine wave of the same frequency. This completes the pulse width modulation and demodulation experiment.
At MSR, you mark your imagination.